So firstly, in this video we'll be looking at rangefinders, what rangefinders actually are and some of the characteristics of them. So essentially, range finding is when we're trying to work out the distance from a current point or a vantage point to a chosen point that we're determining. It might be from me to the camera away, for example, or one point, a robot to a wall that's it's going to encounter. This is normally chosen within line of sight, so we're not talking about we're trying to find the range of a point around a corner. We need to be able to actually see that point. And typically we're going to be measuring that point without actually moving to that point. Otherwise you could use something like odometry by staying here and moving to that point. It's a bit late to find out what the range was to that point because you're already there. So we don't want to move, and we want to work out what that point is, a distant point from our current one. And there's a whole bunch of different applications. And some of them are in robotics, things like robot navigation and obstacle avoidance, but some that we see in everyday life as well. For example, car parking sensors and automatic car parking that we have these days. Surveying, where we're trying to work out distances around to map out an area. Even in sports and things like that. In golf, we work out what the distance to the flag is. And in the military, for example, snipers and artillery need to often work out what the distance is, the range to a particular point that they're trying to target. So we have a few different types of range finding. Firstly, we've got a passive range finding, where we can see an object of a known size, and based on the fact that we know that as the range increases, the object appears smaller, or we can have an object, or we can view the object from several different points, not going right up to it, but viewing it from here and then viewing it from over there and using stereo vision to triangulate the distance. We can also use active range finding techniques, and we'll be talking about each of these. In active range finding, we essentially send some sort of a signal out and we measure how long or how that signal is actually reflected back to us. And based on that reflection, we can work out what the range was. So our first range finding technique is the stagiometric range finding technique. And this is most commonly used in the military for long range sniping. Essentially, it's used to find the distance to objects of a known size. Or, conversely, if we know what the distance is, it can tell us what the size of that object is. Basically, one of the advantages of this range finding technique is that it doesn't transmit anything. There's no light, no sound, nothing like that involved. And so it's pretty well undetectable. So here's a view that we'd see through a typical scope, and if we zoom into that a little bit, we can see that we've got grid lines or marks on there which help with our range finding. Essentially what we do is we line up a person with these range finding graduations, and it will tell us how far away that person is. Assuming that as the further we get away from them, their physical height is going to stay the same, but the observed height, the way that we observe them, changes. So you'll notice we've got graduations of 10, 8, 6, 4, 2, and so we essentially line the person up with that height, and it says 1.7 down the bottom there. So that's calibrated for a person that's 1.7 meters tall. So here's how we'd line it up. So we'd line this person up. Here they line up fairly well with the 4 mark, which is the 400 meter mark. So if we line them up in that mark, and they are in fact 1.7 meters tall, we'd be fairly accurate in saying they're about 400 meters away. Now if they happen to be 2 meters tall rather than 1.7, well, obviously they're going to be further away than what we're actually estimating them to be at. And before we get into all the other fancy range finding techniques, particularly the ones that we use in robotics, let's look at the simplest sensor of all, the bump sensor. Now, essentially this is normally composed of a switch mounted on the robot body, and we have some sort of way that this is actuated, i.e. a wall or a chair leg or something like that. It might be seen as fairly inelegant, but it helps us stop when an obstacle is encountered. And particularly we don't want to damage things within our environment. And some vacuum cleaners, particularly the Roomba vacuum cleaners, for years have used this sort of technique. Very, very simple, very, very cheap, a bit inelegant, but it actually does work. And if you think about how we do range finding in the middle of the night, if there's no lights, what do? First thing we do, we put our hands out and try and feel what's in front of us. We can't happen to see anything, but we try and feel our way through and feel where those walls are. Oh yeah, that's where that chair is, and the stair rail, and all those sort of things. So we actually use this sort of bump or touch or feel sort of range finding technique as well.